So, have you ever built something really cool on your computer? You know, maybe a personal website or a game server you want to spin up for you and your friends, and then you want to actually share it? Well, today, that's exactly what we're going to talk about. We're going to explore how to build that bridge from your local machine out to the global internet, turning your private project into a public one. Let's dive in.
And that is the big question, right? You've got this awesome project, it's running perfectly on your own machine, but to everybody else on the internet, it might as well not even exist. It's totally locked away in your own private digital space. So our mission today is to find the key.
The best way to think about your home network is like a private, isolated island. On the island, all your devices, your laptop, your phone, your console, they can all talk to each other freely, safely, but it's completely cut off from the vast ocean of the internet. And you know what? This is on purpose, and it's a very, very good thing for security.
Now, this separation, this wall, is created by your router. Your router is basically acting as a firewall. Think of it as the guardian of your island, and its default answer to any unsolicited traffic from the outside is just nope. If a connection doesn't start from inside your network, it is not getting in, period.
So, if we want to let people visit our amazing project on our island, we can't just tear down the walls. That would be crazy. Instead, we need to go have a little chat with the gatekeeper, the firewall. We need to give it a very specific set of instructions on who to let in, and, just as importantly, where they're allowed to go. A really key concept to get your head around here is zones. See, your firewall doesn't just have one single set of rules for everything. It's much smarter than that. It categorizes connections based on how much you trust them. I mean, think about it. The level of security you need when you're at home is completely different from what you need on that sketchy public Wi-Fi at the coffee shop, right? Well, each of those scenarios gets its own security posture.
And here's a great example of how those zones work. Public is the most restrictive, absolutely perfect for that coffee shop Wi-Fi where you don't trust anyone. Home is a bit more relaxed, a little more trusting of the other devices on the network. And then there's DMZ, which stands for the Demilitarized Zone. It's a special category built specifically for servers that need to be accessible from the internet. Picking the right zone is always your critical first step.
Now, when we tell the firewall what to allow, we've got two main ways to do it. We can open a specific numbered port, like port 22 for SSH, or we can use a service. Now, honestly, using services is often the way to go. Think of it like this. Allowing the HTTP service is like using a master key that already knows to open the right doors, like port 80 and 443 all at once. It just makes the whole configuration way simpler, and because you're not typing in a bunch of random numbers, it's a lot less likely you'll make a typo.
All right, enough theory. Let's get practical. Let's see how this actually works. We're going to give our gatekeeper the exact instructions it needs to allow access to our service. It really just boils down to these three simple steps. First, we pick our zone. And look, for a service you're exposing to the internet, this is almost always going to be the public zone. Second, we tell it which service, like SSH, or which port number to open. And third, and this is a really crucial step that people forget, we make the rule permanent. If you don't, it's just going to vanish the next time your server reboots.
Then hey, you don't have to be some command line wizard to do this stuff. Most modern firewalls and routers have a nice graphical interface, kind of like the one you see here. You can see how straightforward it is. You just select your zone, you click Add Services, and you pick what you want to allow right from a list. Easy peasy.
Okay, let's throw a little wrinkle in here, because this is a really common scenario. So far, we've been assuming the service is running right on the firewall device itself. But usually that's not the case, right? Your game server is on your gaming PC, or your web app is on a totally separate machine in your network. So how does the request from the internet find its way to the right computer inside your network? Now, some apps try to handle this automatically using a feature called UPnP, or Universal Plug and Play. But for real control and security, we're going to learn the manual method. The answer is a really powerful technique called port forwarding. The super technical term for it is Destination Network Address Translation, or DNAT. When you set this up manually, you're creating a specific, intentional rule that basically acts like an internal receptionist for your network. It tells incoming traffic exactly where it needs to go. It's so much more secure than just letting applications open up ports for themselves whenever they want.
This mail carrier analogy is just a perfect way to get it. So, your router's public IP address, that's Main Street. The incoming request from the internet is addressed to apartment number 80. That's the public port. The port forwarding rule you create says, I see you. Any mail for apartment 80 doesn't stop here. Forward it immediately to this specific house, which is your server's internal IP address, and deliver it to room 8080,
which is the internal port your application is actually listening on.
And here is what that instruction actually looks like as a command. Now, don't be intimidated. Let's break this down because it's not as scary as it looks. We're just telling the firewall to add a forward port rule. Port equals 80. That's the public port, the one people connect to from the outside. Proto equals TCP just specifies the type of traffic. Then we tell it where to send that traffic. To tow port equals 8080 is the port your app is listening on inside your network, and to address equals 198.51.100.10 is the internal IP of your server. See? That one command creates that perfect invisible bridge.
So, we've done it. We've built our bridge. The world can now get to our amazing creation. But here's the thing. With great accessibility comes great responsibility. Every single door you open can be used by your friends, but it will also be tested by strangers.
And don't just take my word for it. This quote is from the National Institute of Standards and Technology. And it's not a maybe. It is a certainty. The absolute moment you open a port, you are on the map, and automated tools will find you, and they will see what's open.
This whole automated process is called probing, and the rattling doorknobs analogy is absolutely perfect. It's literally millions of bots that are constantly sweeping across the entire internet, checking every single door on every single house to see if it's unlocked. And if they find an open port, say for SSH, they'll often start an immediate automated attack, like trying thousands of common passwords to just brute force their way in. They're not targeting you specifically, they are targeting everyone with an open door.
So how do we stay safe? First, the principle of least privilege. Only, and I mean only, open the ports you absolutely need. If you're not using a service anymore, close its port. Second, strong passwords are your absolute first line of defense. Make them long, make them unique. Third, keep your software updated. Those probes are often looking for specific known vulnerabilities that developers have already patched. Updating closes those holes. And finally, check your firewall logs. They will show you who's been rattling your doorknobs, and they can reveal patterns, like repeated failed login attempts from one IP address, which is a dead giveaway of an attack.
At the end of the day, it's all a balancing act. The firewall isn't about blocking the entire world out. It's about letting the right parts of the world in and doing it on your terms. It gives you the control to decide where you want to live on that spectrum between total isolation and wide open accessibility. So now that you have the tools, there's really only one question left. What are you going to build and share with the world?